behavioral patterns. Behavioral patterns are the patterns that are concerned with communication between objects. So all these patterns, strategy pattern, template method pattern, visitor pattern, and command pattern, and so on, these are all patterns that are concerned with communication between objects. So let's start with the most popular, I would say, pattern called the strategy pattern. What is a strategy pattern? So strategy pattern, a class behavior or algorithm. So these two terminology, behavior, and algorithm, I'm talking about using these two terms. I'm using these two terms interchangeably here. So behavior can be changed at runtime if you're using strategy pattern. And basically in strategy pattern, you are going to create the multiple strategies. Each of those strategy objects represent a particular behavior. And the context object will be injected with this strategy. And so the context object, its behavior will be changed depending on what strategy object is going to use. So when do you want to use a strategy pattern? Use it when different behavior needs to be selected during runtime. I think Randy's question in terms of composition over inheritance, this is in fact quite relevant here. If you're using inheritance, you cannot really change the behavior of a class during runtime. In fact, the behavior is fixed because it's in fact inheriting a behavior from a parent, right? But if you're using strategy pattern, which is using composition, the context has a dependency object. That dependency object in this case is going to be strategy object. And by injecting different strategy dependency object, the behavior of the context object could be changing during runtime. Okay, participants in strategy pattern. So strategy is going to be made of an abstraction and set of concrete strategies. So strategy, this is an abstraction. It could be either interface or an abstract class. As I said before yesterday, whenever I say abstraction, in Java, it could be in a form of Java interface or it could be in a form of abstract class. So strategy abstraction declares an interface common to all supported behaviors. So basically all behaviors that should be the common should be declared in strategy in an abstract fashion. And context uses this interface to call the behavior. So inside the context, it will have a reference to this type. Okay, but the real object will be from concrete strategies. So concrete strategies are the one that implement concrete behavior, implementing strategy interface. And context object maintains a reference to strategy object, and then client will actually use this context object. Okay, and I'll come back to this slide after we look into the lab. Okay. So if you don't understand what I'm talking about on that slide, don't worry about it. So let's do the exercise. So we are going to take a look at a few exercises. So I am going to give you two examples, and then we're going to actually take a look at the general structure of a strategy pattern. So I'm going to start with compute price. Before and after. So before is the one that doesn't use a strategy pattern, and after is refactored with strategy pattern. So in this case, what we want to do is we have a shopping cart, and depending on discount type, so we have weekend hour and weekday hour, and depending on this discount type, we'd like to compute the price of a product differently. Okay, so if you so this is the case that we do not use strategy pattern. So we have a shopping cart. So shopping cart has the discount rate 10% for weekday, and if it is weekend, it's 20% discount. Okay, and we have a list of items, and so this is the method that computes discounted price, okay, for a particular item. Okay, so this is the bad part. So whenever there is undesirable coding, bad design, I actually prefixed with bad the comment. So in this case, you see if and else statement here. So whenever you see if and else statement, you need to suspect that is a design flaw. So in this case, whenever, so we compute the actual price based on discount type. So if it is a weekday hour, we are providing 10% discount. So the actual price is going to be price times quantity and then the 90%, so 10% discount. And this is the case of weekend discount, so we give 20% discount. Okay? Now the problem of this code is whenever we need to introduce different discount type, for example holiday discount rate, then we have to change this code, which violates the open-close design principle we talked about, right? Okay, so open-close design principle says that you should be able to extend the class. If you want to add new feature, you should be able to extend it, but not actually modifying existing code. So that is the open-close design principle. So in this case, if you introduce a new discount type, then you have to change it. Okay. And in the client code, we basically create a shopping cart object, and then we are basically computing the prices. So if I run this code, let's just run this code. Okay, so this is the price. All right, now we are going to refactor this code to use strategy pattern. So what we need to do is we need to have the compute strategy interface. So here, this is the I compute price strategy interface. So here we have defined compute item price method, and different behavior will be captured as a concrete classes which implement this interface. So here we have weekday compute price. This is the strategy. So this is one behavior or one algorithm. So this is a varying part. Okay. So it implements I compute price strategy, and this computes the weekday pricing. Okay. So this is one changing behavior. And then we have a weekend computing price. Okay. And this is the changing behavior. So this is computing weekend discount price. Okay. All right. So both of these concrete strategies implement this abstract strategy. Okay. And then we have a context object. So in this case, context object is a shopping cart. So shopping cart will be injected with this dependency object, and this dependency object is the type of this I compute price strategy interface. So that compute strategy will be injected, okay, through the constructor. Okay, and then the compute item price, this method will be just using this strategy, right? So the good part is that code now uses the strategy pattern. This code does not need to be changed even if we introduce new strategy, for example compute price strategy for holiday, because we are using this abstraction. This abstraction is interface type, right? So in order to support holiday pricing strategy, only thing you have to do is basically, so let me actually show you the UML diagram. Okay, so here this is the I compute pricing strategy. This is the abstraction. Then we have a concrete strategies. Okay, and the context object will be injected one of these concrete objects as a type of this interface. Okay, so whenever you see this line, that means this one has a dependency, has a reference to this dependency object. Okay, so if I want to support different compute price strategy, then all I have to do is basically, for example, like a holiday compute strategy, then I just create holiday computing price strategy, and that's pretty much all you have to do. Okay, there is no change in existing code. You don't have to change this context object, shopping cart context object. You don't have to change any of this, right? So you basically add the class to support new functionality. So in this case, a client code. So here we are selecting a particular strategy during runtime. Okay, so again, I'm actually using this code to create the weekend computing strategy, but this could be generated during runtime, maybe through again command line argument or factory class and things like that. Okay, so this is selecting of one pricing strategy during runtime, and so we choose weekday strategy, and here we choose weekend strategy. So here you could in fact have a method that actually determine which computing strategy that you want to create depending on some business logic. Okay, all right, so if you run this guy, run as and Java application, and it should actually compute weekday pricing and weekend pricing. Okay, all right, so that is computing strategy, computing price strategy pattern. Now let's take a look at another example. So in this case, I'm going to actually show you payment scheme. So here we have a shopping cart object, but this time what we want to do is we want to be able to use different payment scheme. So here we are using credit card, and here we are using PayPal. Okay, so if you take a look at the shopping cart here, this is the bad part. Again, you see if and else here, right? So here, if new payment method needs to be supported, okay, for example, cash payment, then I have to change this code. So in this case, depending on whether payment method is PayPal, we are using PayPal, the payment scheme. Otherwise, we use the credit card, right? But if I want to support cash payment, then I have to change this code. And again, that violates open close design principle. Okay. All right, so here we have credit card, which contains name, card number, CVV, and the date of expiry and things like that. So it has its own behavior, pay method behavior. Okay, so again, I'm just displaying this statement, but this is where the credit card specific payment scheme should be implemented. On the PayPal, same deal. So it's a pay method, and it does have its own business logic, which is in fact changing part of the application. Okay, so what we want to do is we want to use strategy pattern so that we don't violate the open close principle. So here again, if you want to support cash, then we have to change if and else logic in the shopping cart. Okay, so we are going to refactor that code to use strategy pattern. Okay, so here we have to create, so we have to actually abstract this pay method. So in strategy pattern, basically you are going to abstract the changing part of the each strategies. So what we need to do is we need to capture this pay as an abstraction. So that's basically payment strategy. So payment strategy just abstract pay method, right? And each concrete implementation of this payment strategy now will actually provide changing part of that particular strategy. So let's take a look at credit card strategy. So credit card strategy will actually implement this payment strategy, and then again, this is changing part of pay method for credit card strategy, and same thing with the PayPal strategy here. Okay, so it has to implement pay method of this changing the aspect of the strategy. Okay, and then shopping cart context here. We are implementing pay method and is receiving payment strategy. So this is a dependency, right? So this dependency could be injected through a constructor or setter method, or in this case we are injecting that payment strategy object as part of the method, as a method argument. Okay, so it's receiving this strategy, and then it will just call the method of that strategy. So again, if I want to introduce, so let's actually take a look at the UML class here. So we have a payment strategy, which has a pay method, and then credit card strategy will implement differently in his implementation of pay method from PayPal strategy's implementation of the pay. And the shopping cart context should have reference to in this case it doesn't have a reference because it's actually receiving it as part of the pay method argument. Okay, so if I want to introduce another payment strategy, let's say cash strategy, all I have to do is to create the cash strategy here, and that's all you have to do. And then client will select a particular payment strategy during runtime. Okay, so let's run this guy, and I'm going to in fact add the cash strategy. Okay, so we run it, and here $50 paid using PayPal. So now I want to support the cash strategy, so I'm going to just copy PayPal strategy, and I'm going to add cash strategy. Cash strategy. Okay, so I added the cash strategy. So here, yeah, we don't need all this. So yeah, we'll just base amount maybe. Actually, we don't really need any of this. Okay, so I'm gonna just provide dollars using cash, something like this. Okay. All right, so now in order to use this cash strategy, so in the client, basically I am going to yeah, so this is an example where we are determining which payment strategy to use during runtime. So let me just show this code. So here we create a shopping cart context object, and we have created 2 items, and we add those 2 items to the shopping cart, right? And then we want to pay. So we call pay method on the shopping cart, okay? And this is the method that will call. So I actually have decide which payment scheme to use. And so you could choose different payment strategy during runtime based on business logic. So in this case, I'm just using I hard-coded this test like a true, but this could be some business logic. It could be depend on time of the day. It could be depending on your mood, depending on whether the customer is actually a good customer or not. All those business logic could be used instead of true here, and then it will determine which one to use. Okay, so for the sake of this exercise, instead of using a PayPal strategy, I'm going to use a cash strategy. And I don't think I need to pass anything here. Okay, so in this case, instead of using PayPal, it will actually choose cash strategy based on some business logic here. Okay, so let's run this guy, F11. So now it's paying $50 using cash. Okay, so the idea is, in order to support different behavior or different algorithm, only thing you have to do is to create another concrete strategy class and basically use that the strategy object during runtime. Okay, so now by the way, I have a test code. That's the reason it fails. So I'm gonna just remove this test code for now. Okay, so let's take a look at the general case. So if you take a look at the general case, again, this is before. So these are reflecting. There are two algorithms and there is a context. So in this case, in the context object, this is the bad part. Depending on which algorithm to use, meaning depending on which behavior you want, you have to use either if and else or case statement. Okay, so if algorithm 1 is chosen, then we are creating algorithm 1 object and do something. So if you take a look at algorithm 1, this do something is the changing behavior depending on algorithms. Okay, so in this client, I'm going to just run this guy, run as, and job application. And so it's actually using algorithm 1, algorithm 2, so two different behaviors. Okay, now if you need to add algorithm 3, then again you have to change this context object. You have to use another case statement, and that is basically violating open close principle. Okay, so now we are going to use a strategy pattern. So this is a strategy pattern. So we have to create a strategy interface that captures the changing behavior. So that is this do something behavior. So if you take a look at the I strategy, we are basically capturing that changing behavior as an abstract method, do something. Okay, then we have a concrete strategies implementing that do something behavior differently. So this is concrete strategy 1, and here we are just changing to uppercase. Concrete strategy 2, we are just changing to lowercase for the sake of changing behavior. And then in the context object, in this case, the strategy object will be injected through the constructor. Okay, so the context object has a reference to strategy object using this iStrategy abstraction. Okay, and then this strategy will be injected through the constructor method. Okay, and in the client code, we basically select a particular strategy during runtime. Okay, so here we are using concrete strategy 1, here we are using concrete strategy 2. But again, the determination of which strategy object you want to use could be determined during runtime based on business logic. Okay, so if I run this guy, run as and job application, and it should work pretty much the same. Now I should be able to add the concrete strategy 3 without changing existing code. Okay, so hopefully, by the way, so let me actually talk about the composition versus inheritance. That's what Randy was asking. So if you take a look at this context object, okay, the strategy object is, we are using composition here. What that means is that strategy object will be as a dependency in the context class. Okay, instead of context classes maybe extending some strategy or something like so. This is the composition. So as I said before, composition has a relationship, while inheritance is a relationship. So in this case, context has strategy object. So between context and strategy, it has a relationship, and that is called composition. Okay. All right, so now let's do, let me actually explain the homework, and I'll give you guys time to play around with the strategy pattern. I'll give you guys enough time to do strategy pattern, the exercise. So the homework is you're gonna create say greeting, so let me actually use the documentation here. So in this case, build a greeter system with the different greeting strategies. So I want you to create a morning greeting strategy or afternoon greeting strategy. So obviously morning greeting strategy will say hello, good morning, and afternoon greeting strategy will say good afternoon, depending on some business condition such as time of the day, or you can hard code it for the homework purpose. Okay, so here you are going to uncomment the client code. Okay, so here we are going to create greeting context object first, which will be injected with the greeting strategy. Okay, and so we are going to call decide greeting strategy method. So here decide greeting strategy method, we are going to just simulate the selection of a particular the greeting strategy, and so it could be either morning greeting strategy or afternoon greeting strategy based on some business logic. Okay, in this case we are just hard coding true, right? And then you need to create these two greeting strategies, right? So if you take a look at the I greeting strategy, what is the varying part in this case? It probably just say message or say greeting or something like that. That is the changing part, right? Okay. Yeah, so that's basically, yeah, so the get greeting message. So internally it will probably, yeah, so the changing part is probably getting the greeting message or something like that. And then you create a context object. In this case, the context object is a greeting context right here. So yeah, so that's the class that you need to create. Okay. All right, so that is, and also, I want you to add another strategy. So here we have good morning strategy and the morning greeting strategy and afternoon greeting strategy. I want you to add evening greeting strategy as well, and making sure no existing code is being changed. Okay. All right, so I am going to